Welcome back to thermochemistry and thermodynamics. In part 3 of this video, we're going to look at 2 more ways to calculate delta H, specifically using Haas's Law of Heat summation and enthalpies of formation. Let's get started. So Haas's Law of Heat summation says that if a reaction is carried out in a series of steps, the overall change in enthalpy will be equal to the sum of the enthalpy changes for the individual steps. In other words, add up the individual steps and you'll get the total. The overall change in enthalpy would be the same if the reaction was carried out in only one step or multiple series of steps. Sometimes, in order to use this process, we're going to be using the delta HF values from that reference chart that you used in our last video. So, delta HF stands for the enthalpy change of formation. F stands for formation. You'll notice this little degree symbol. Frequently you'll see that degree symbol. This means they're in their standard state. And the standard state is 1 atmosphere pressure and typically 25 degrees C. That is not STP. STP is 0 degrees Celsius. This is standard conditions, 25 degrees Celsius or room temperature. So delta HF is how much heat will be gained or lost during the formation, that's what the F stands for, of 1 mole of a compound from the most common form of its elements in their standard states. That's what the degree symbol stands for. The delta HF value for the most stable form of any element in its standard state is 0. So essentially, we're saying that all elements were created when they were created and don't take any energy to create. Other things made from elements do take energy to create. So if you looked up the element iron, its delta HF would be 0. Or if you looked up the element oxygen, its delta HF would be 0. Even though oxygen is O2, that's the standard form of oxygen. For carbon, there's actually several. You can have carbon gas, or carbon diamond, or carbon graphite. If you look on your chart, find the carbon that's 0. Graphite. That's the standard, what carbon typically looks like at 1 atmosphere pressure and 25 degrees. So carbon graphite is 0. A lot of times notebooks or tests will refer to that as carbon solid, but I just want to make sure that you know carbon solid, they're not referring to doing reactions with diamonds, they're referring to doing reactions with coal. So let's look at Haas's Law of Heat summation, a series of steps that's going to add up to give the overall final step. I think what this slide is missing is a little blank here for our final answer. Okay, so we have an overall reaction. 2CO plus O2 is going to make 2CO2. And we're going to make that reaction using these 2 reactions. Carbon graphite plus half oxygen makes CO, and carbon graphite plus a whole oxygen makes a CO2. So we're going to rearrange reaction 1 and 2 to get the overall reaction from the top. Notice the overall reaction from the top has carbon monoxide as a reactant. Notice the only carbon monoxide in the reactions at the bottom is on the product side. So this reaction is going to have to be reversed. So we're going to rewrite it in reverse order. CO arrow C plus half O2. We're reversing the order, so the delta H is also going to be reversed, positive 110.5. Because I need carbon monoxide to be a reactant, so I'm going to have to flip that entire reaction. Now I'm going to obliterate what we had here so I don't get confused and think that I haven't used this. I'm just going to cross that out. So now, another step, we're going to try to make sure the top matches the bottom. This was 2CO. And so if I need 2CO, I'm going to double everything. 1/2 times 2 is just a 1. And then multiply this by 2. Make sure everything changes, delta H changes with the reaction. And then For the product, I see 2 CO2, which is fine because this is a product like it should be, but there's only one of them. So I'm going to multiply this entire reaction by 2. 2, 2, 2, and 2. Now let's add it up and see what we get. I see that there's 2 carbon graphites on the left and 2 carbon graphites on the right. Those cancel. I see that there's 2 oxygens on the left and 1 oxygen on the right. One of them cancels, and the other, only one of them cancels. What's left over is 2 CO and 2 CO2. Oh, I skipped one. 2 CO and an oxygen, and the product side was 2 CO2. Does this match this? Yes, then the reaction is good. Then all I have to do is add up my delta H's. 2 times negative 393.5 is negative 787. 2 times positive 110.5 is positive 221. Add those up, negative 787 plus 221, and I get negative 566 kilojoules. Let's try another. In this problem, there are no reactions given, but Hess's law of heat summation says we're summing up reactions in a series of steps to give the overall. So we're going to make our own formation reactions. So, for example, I can see in this equation NO2 is going to need to be formed. So I'm going to make NO2 as a product. Now, a formation reaction is from its elements in their standard state. Not the way a reaction would really happen, but just from its elements. So nitrogen dioxide is made up of nitrogen and oxygen. Nitrogen dioxide is made up of nitrogen and oxygen. Now we have to keep the nitrogen dioxide with a 1 in front of it, so we're actually going to half the N2 so that we keep nitrogen dioxide with a single only 1 here. Now look up on your chart, that reference chart, and your delta HF values, find NO2. It's under the nitrogen section. It's on the second page, in the bottom, on the left. Did you find it? Okay. So delta H for NO2. That's just one NO2. Is 34 kilojoules per mole. Now in this reaction, there's actually going to be 4 NO2s. So if I put a 4 here instead, then instead of a half N2, this would be 2 N2, and this would be 4 O2, and this would be 34 times 4. Let's do another one. Water is formed, so we're going to write a formation equation for water. H2O. Water's made from the elements hydrogen and oxygen. And if we balance it with a 1 in front of the water, I'll need a half an oxygen. Find water on your chart. Notice that there are 2. Make sure you're looking at gas water instead of liquid water. Go ahead, find it now. Hopefully you found 242, negative 242, sorry. But really there should be 6 waters. So I'm going to multiply this by 6, and multiply this by 6, and a 1/2 times 6 is a 3. Oh, and then obviously multiply this guy by 6. Okay, so now let's look at the other 2 things we have, the reactants. The reactants are not being formed, they're being broken. So we're going to make the opposite of a formation reaction, decomposition, I suppose, NH3, and we're decomposing it into its particular elements, the elements that make up NH3. That's N2 and H2. Now, this is going to be 4 NH3, so 4 times NH3, so I'll need 2 N2s and 6 H2s. So when I find that number off my chart, I'm going to multiply it by 4. 4. Also, since this is a decomposition, not a formation, when I find the number off my chart, I'm going to switch its sign. If it's positive, it will become negative. If it's negative, it will become positive, because this is not a formation reaction. This is a decomposition reaction. So find ammonia. Make sure you're looking for NH3 gas. It's in the nitrogen section. It's negative 46. So since it's negative 46 and I have to negate that, this is going to be positive 46. And then for oxygen, you don't have to do anything. Because oxygen is an element, it does not require formation. If you look up the delta HF for oxygen, go ahead, look it up. It's 0. So since it's 0, it's nothing. We're not even going to worry about that reaction at all. Let's add up what we have. Notice that there's oxygens all on the left-hand side, so those are going to add together. Ooh, 2 nitrogens on both sides, those are going to cancel out. 6 hydrogens, those are going to cancel out. I don't see anything else that cancels, so everything else looks like it's going to stay the same. I like to circle the things that we're keeping and X out the things that we're losing to make it easier to see so we don't mess up. So this is going to be 4 NH3, and 4 plus 3 is 7 oxygens, and then 4 NO2s, and 6 waters. Does this reaction match that one? Yes, it does. My reactions are good. And as long as I changed my delta H with my reactions as I'm writing my reactions, then my delta H's should add up well the same way. 34 times 4, 136. 6 times 2, 42, negative 1452. 46 times 4, 184. Just add those all together, sum it up, and I got negative 1132. Please check me, make sure you got the same thing as I did. Negative 1132. Okay, let's try another. So here's my next problem. Again, the reactions are given for me, so all I have to do is rearrange these reactions to find the overall. So this is the overall that I'm looking for, and I've got to rearrange 1, 2, and 3 to make that overall. So look at the overall reaction. Notice that carbon graphite is a reactant, and there's 3 of them. In your reactions, the only place you see carbon graphite in reaction 3 is as a reactant, which is great, but there's only 1 of them. So let's multiply this by 3. 3, 3, don't forget over here, 3. Okay, let's go on to the next one. I see 4 hydrogens as a reactant. Within my other reactions, I only see hydrogen as a reactant, or at all, just once, but there's only 2 hydrogens. So let's multiply this reaction by 2 to make 4, 2, 4, and 2. Multiply the entire reaction by 2 to get me my 4 hydrogens. Okay, back up to the original, C3H8 as a product, and there's only 1 of them. Oh, but reaction 2 has C3H8 as a reactant. There's only 1 of them, so that's bonus, but it's a reactant, not a product. So this reaction is going to have to be rewritten completely backwards. So rewrite reaction 2, 3 CO2 and 4 H2O. Let's make that a prettier H2O. Those are my reactants that used to be products. And then C3H8 and 5O2, those are my products that used to be reactants. then my delta H is going to change the same way, positive 2220.1 instead of negative. Now we're going to add up the reactions and see what happens. Well, I see that there's 5 oxygens here on the left. Ooh, but there's also 5 oxygens on the right, so that's going to cancel. Let's see. Ooh, I see 4 waters on the right and 4 waters on the left. That'll totally cancel. And 3 carbon dioxides on the right and 3 on the left. That'll cancel. Nothing else looks like it'll cancel. What's left over? 4 hydrogens, 3 graphites, a C3H8, 3 carbons, 4 hydrogens, a C3H8. Does this reaction match that one? It does! Check! The reaction's good. So all we have to do is add up the delta H's. 571.7 times 2, negative 1143.4. Let's see, negative 393.5 times 3, negative 1180.5. As I'm doing this, you should also be doing this. Check my math. So I get delta H is negative 103.8 kilojoules. There we go, delta H. All right, last one. This one you get to do all by yourself. Pause the video now. Do it. Pause the video now and try it on your own. Did you pause it? Okay, let's go. Trying to make my overall reaction using these individual reactions, 1, 2, and 3. I see CaOH2 aqueous on the left, so CaOH2 aqueous needs to be on the left. So what I'm going to do is reverse this reaction by changing this to an aqueous and changing this to a solid. And then that will change that to a positive. I see 2 HCl's here, 2 HCl's there. That's good. I see a CaCl2 on the right, a CaCl2 on the right. That's good. I see 2 waters and only 1 water. Oh, well, that's going to be a problem. Do you see any other places where that other water might come from? Because we just said we're not going to multiply this by 2 because of the calcium chloride. Oh, you do see that other water. Oh, look at that other water. But in order to make these 2 waters go together, they have to be on the same side. Otherwise, they're going to cancel if we left them the way they were. Plus, if you notice, this is CaOH2 solid, and we just put CaOH2 solid down here. So those 2 would add together instead of canceling. Again, that's not something that we want. So we're going to take reaction 2 and reverse it. So that'll be CaOH2 solid as a reactant, CaO and H2O as a product, and that will change delta H by making it a positive 62.3 instead of negative. Remember to kind of obliterate this reaction so you don't get it confused and think there's an extra additional reaction here. We've replaced reaction 2 with a new reality. Now let's add up what we have. Now there's 2 waters on the right-hand side like there should be. The CaOH2 solids are going to cancel out. The CaOs are going to cancel out. Nothing else looks like it's going to cancel out, so everything else I'm going to circle to say keep it. So overall, I will end up with CaOH2 aqueous and 2 HCl and CaCl2 and 2H2O. Make sure you check yourself. Does this reaction match that reaction? Yes, it does. So all we have to do is add up the delta H's as they are. Negative 186 plus 12.6 plus 62.3. Delta H is negative 111.1 kilojoules. That was Hess's law. Now, Hess's law can also kind of be used, or at least when you have to do the heats of formation, with enthalpies of formation. This is a formula you might be more familiar with from Chemistry 1. Essentially what we're saying is, to find the delta H, we're going to take the delta H formation for the products minus the delta H formation for the reactants. Products minus reactants. This formula exclusively uses the delta HF values. Reactants are given a negative value. It's minus reactants because the bonds are being broken, not formed, because this is delta HF for formation. Let's do our example. So when we're doing enthalpies of formation using products minus reactants, it's very important to realize what is a product and what is a reactant. So products are always going to be at the end, and I'm going to help by color coding here, and reactants are always going to be at the beginning. So let's start with the products. The products as written is 4 CO2 plus 2 water. So we're going to put a bracket and say 4 times CO2. Except in place of CO2, you're looking on your reference chart for carbon dioxide. That should be on the front page with the carbons. Did you find it? That's negative 393.5. We're just taking the number as is straight off the chart. So 4 times CO2 plus 2 times water liquid. Make sure you're not looking at water gas. Water liquid, negative 286. That's the products. Minus, for the reactants, 2 times the number for C2H2. So find C2H2 on your chart. That's 227 plus 5 O2. The number for O2 on your chart, look it up. It's 0 because it's an element. And bracket that. So now we're going to simplify. 4 times negative 393.5, negative 1574, plus negative 572. Those are products minus reactants. 2 times 227 is 454. Simplify a little bit more. Negative 2146 minus 454 equals negative 2600 kilojoules. So that's using products minus reactants. That's actually the College Board's least favorite way to find delta H. They feel like that shows the least amount of understanding on what you're doing. So it's less likely that they'll ask you to use that formula. But also it's the most common outside of what the College Board does. That's the most common way to find delta H. Okay, well that was 2 more ways to find delta H. Tune in next time and we'll go for number 4. We'll see you then.